welcome everyone. Thanks for coming along tonight. As you know, tonight's the new venue, so Oliver's had a little bump and will be out of action for the next 2-3 months. Busy with it, as you can well imagine. So we're going to be here at the Entain office, and then we'll sort of work it out if we go back to Mantle or carry it on here after that, which should be cool. So if you're wondering where he is, that's it. And then I'm going to be helping out if anyone else wants to help out as well. I think we've got a few other people sort of filling in the interim. Yeah, just get in touch on the Coca Head Slack. So we've got all the meetups chucked up, the upcoming ones, but it's the third Thursday of every month. And then we've got the Brisbane meetup channel there. QR code, if you're not on that, that's kind of where all the action happens for discussions, or you can sort of message people and get in touch with others. Lots of good opportunities to connect there. So yeah, welcome. We've got a few new faces tonight. We've got some people from university, which is pretty cool, so welcome. Big round of applause to you guys coming along. Also to have some fresh blood in here, we've got Adam over here. Adam's the head of design here at Entain. So are you ex-iOS, are you? Yeah, ex-iOS. Published book, is it, on design?
Oh, I don't know about that, yeah.
Yeah, he knows his stuff about design. We've got John at the back as well. John's head of platform here at Entain. A few other Entainers, ex-Entainers here as well. For those of you that aren't aware, Entain is sort of we have a collective of apps, so Tab in New Zealand, Neds, Betcha and Ladbrokes. So a whole bunch of racing and sports apps. So we've come on as the venue sponsor for the evening. Bit of housekeeping, we've got toilets. If you haven't found them already, they're just to the left of the kitchen there, straight through there, men's, women, disabled. And then also fire exits just keep on running past the toilets and down the stairs. I had to find out where they were, I just had no idea. They're kind of hidden. So yeah, good to point that out. As I mentioned, Entain has jumped on as the event sponsor. We've got drinks. John's actually the sponsor of the drink. So yeah, big thank you, John. As you know, gambling companies are struggling at the moment. They don't really make much money, and John had to reach for his wallet to make sure the fridge was stocked up for you guys, so thanks to you. And food, of course, Mantle Group, so they've come on and, half the reason why you guys are here for the pizza, of course, so yeah, big thank you to Mantle Group for continuing to sponsor that in Ollie's absence. As I mentioned, if you're not already, feel free to scan the QR code and join us online, that would be awesome. Little announcement, meetup name, across Australia and New Zealand and the rest of the world, there's kind of a unanimous name for iOS meetup groups, which is Coca Heads. So it used to be the name, then it went to Brisbane.Swift, and now it's kind of going back to Coca Heads Brisbane, so just creates consistency with the rest of the group, because if you scan the Slack and go into that across the New Zealand chapters and Australian chapters, it's all referenced as Coca Heads. So just to keep it consistent as people move around and to align with everyone, that's going to be the new name, so formerly Brisbane.Swift. But yeah, just a little clarification there. We'll keep both in there for the search engine if you're searching one or the other, but just creates a little bit of alignment. Upcoming events, we're in the works of actually working with Apple on the next speaker, so they might be able to get a little bit of budget there on the D-Lo to fund a speaker coming up from Sydney. So we're working on a woman speaker to come up who's done quite well for herself for March, which would be really cool, so that's for International Women's Month. April, was thinking having some short fire lightning talks. I know there's some new faces here, there's people working on different things. Many people sort of have never done a talk before, so instead of jumping into a fully committed talk like we have tonight, it can be a good opportunity to sort of practice your presentation skills and have a bit of a short fire lightning talk. So it can be a minute long if you want to just go up and present something, or present something that you've been working on, or something you've learned, or you're even just showing off your side project. The barrier is just really low. There's no barrier to entry. You can just get up and waffle on about anything. You don't even need presentation slides, just plug in, show Xcode, walk through what you're doing. So yeah, we'll be putting a call out for people to jump in for that, which will be really cool. Look good on your resume as well, and get lots of nice photos and stuff for your LinkedIn or whatever as well. Make you look part. Even got a nice pedestal as well, super professional. And then scheduled in for May, we have potentially a reverse engineering talk to be confirmed.
I think it should be good.
Should be good. I know I'm really excited about that. I'd love to learn a bit more about reverse engineering apps. So yeah, that should be a really good one to look forward to as well. So they're all posted up on meetup.com as well. So get in your RSVPs for that. There's a correlation between RSVPs on Meetup and the pizza we order. So make sure you RSVP. Otherwise, there's not going to be pizza. So that's what it's being based on. So yeah, please reach out. I'll chuck at the end of it, chuck the QR code back up there, but please reach out. There's the Brisbane Meetup group, chuck it in there. If you'd love to have a talk on anything at all, even a lightning talk, please don't hesitate. You know, the bar's low. Just reach out, have a crack. It'll be so good for you. So agenda, food, we've got pizza and everything. Feel free to just go up, grab some more pizza. We've got drinks in the fridge over there. Just go up during the talks or whatever, help finish it off. We don't have to throw out perfectly good pizza. And then otherwise I'm going to be handing over to Josh, who's going to be doing a talk on Google's MedGemma new machine learning model, right?
Yes.
Yeah.
Yes, I will be. Yeah.
Running AI on a device,
Locally.
machine learning,
Yeah.
locally on a device. So yeah, hand over to
Exciting
you.
stuff. Thank you. Thank you so much.
That's right.
Okay, hey guys, this is my talk on introduction to MLX and Swift transformers, on-device LLM models using MLX. Okay, a little bit about me. So I'm a self-taught iOS developer. I'm recently become a dad in like the last few months. I'm an indie app developer and I'm a bit of an AI enthusiast. So these are some of the apps that I've got, well, in terms of a published self-taught iOS developer. So Nutrify, the whole food tracker, is live on the App Store, as well as KeepTrack AI Home Inventory. Step with Friends is actually not an AI app, so I've gone back away from AI. So it's literally just steps, collate them with friends, so then you can like kind of race each other or rank each other based on steps. And Sunny will be the app that I'll be talking about later later tonight. So Sunny is the app that we built based to use MedGemma, like Google's new MedGemma AI. All right, why on-device models and why not just use a cloud model? So the one big thing that I see with on-device models is the privacy. So you get that 100% money-back guarantee on your privacy. So your data's not going to be harvested by some big corporation, essentially. So it's going to stay completely local. On top of that, you're getting very fast inference because it's all happening local. And these models have been kind of like compacted down to run best on device. And they're also using Apple's new MLX framework. So Apple have been like sleeping on the whole AI. People have been saying they don't have their own thing. But I feel like they've really been putting a lot of work into their on-device capabilities, and that's seen in their foundation models and then this now open source MLX framework, which allows like third-party LLMs, VLMs to run natively on the device. Zero AI bills, so if you've ever leaked your API code or anything like that accidentally by committing it somewhere that you shouldn't have, you don't have to worry about that with on-device models. They run off memory, essentially. No connection issues, so you've got zero downtime. One big thing with like models, especially the ones that I've been using for Nutrify and KeepTrack, is handling the cases where, for example, inference stops or stops streaming or people drop out and all that sort of stuff, and then you've got to keep people in the loop. But when it comes with like design and all that sort of stuff, that user experience where like if the model fails or you lose connection slowly, then the time to basically get essentially your prompt or your response back is just going to blow out massively. And then actually on that, Nutrify, this is one of the things we had to tackle because it's a food scanning app. So if you were to use Nutrify in a shopping centre, a lot of shopping centres around Australia have just the poorest reception known to man. So there are some fallbacks for Nutrify. It does run 2 offline models already. But we do use Gemini in Nutrify as well for like a multi-food scanning purpose. What is MLX? So this is Apple's model framework. MLX is an open machine learning framework developed specifically for Apple Silicon. MLX is basically been made to run third-party models natively on the Apple chipset, essentially. So this uses the unified memory and it helps with memory saving and battery savings. Swift Transformers. Swift Transformers is made by Hugging Face. Hugging Face, for those people that don't know, is just basically a large GitHub repo for open source models, or you can even host, like GitHub similar, you can just host private models as well. So I'll also show how you can load in private models if you don't want to share with everyone else. There are thousands of models up there for like the MLX framework already. Some of them are by big companies that have made on device, like they've taken their big models and they've basically condensed them down to be able to run on these MLX frameworks. Yeah, Swift Transformers also handles a lot of that nitty-gritty and kind of bridges the gap between like getting a model from essentially just pulling one out of thin air and trying to run it on the device. So they handle a lot of the tokenization, so that's like the inputs, which can be a pain when trying to use these on-device models or using a model in general. And then also, yeah, having them with the Swift Transformers, they also handle the downloading. So when you're publishing an app, it can only be of a certain size, right? So you can't have like a 5 GB model baked into the app trying to push that out. Like someone's trying to download your app, they're going to be there for a while. So Swift Transformers also handles the download very quickly and efficiently and saves it on device from Hugging Face as well. So they've really boiled it all down to make this as simple as possible to get like device, like machine learning models running natively on your device. Model shopping. So one thing is like what models can run on your device. So if someone who may not know what can and can't run on your device, you know, going to Hugging Face's website and just looking at all these models, you're going to be like, okay, I don't even know what one's going to work for me, like what's going to run on what device. And then memory is a big one, like I said before, or pointing on this one a lot, memory, it's literally running in the RAM. So most iPhones have anywhere between 6 to 8 gigs. Now I'm talking about specifically iPhones. You could run these on Macs as well. So like it runs across all Apple's chipsets. So if you have a Mac with a larger memory, you could imagine you could have much more context loaded into one of these local models. Quantizing is essentially just like the compression. So compressing a model down to be able to run on a phone. And then, yeah, with that compression, it affects performance and also outputs. I find the sweet spot on model sizing, depending when we get back into actually shopping for a model, anywhere between 50 megabytes to 4 gigabytes. So 50 megabytes is basically like I would say like a one-shot model, essentially. These are 2 of the models that we run in Nutrify. So they just do one thing, which is like image in, label the food, like what food is this essentially? Or another layer that we have to protect from food images that aren't food going into our food tracking app is a vision layer that will basically go, is food, not food, essentially. So it'll only let you scan if it is food. Awesome. Context, yes, context is a big thing again. Memory, because the tokens in and tokens out all compile into that memory as well. And yes, if you're going to be using this, get ready to run into a bunch of Swift memory warnings, crashes as well when playing around, because yeah, Xcode likes to dump your app when you're using too much memory.
If you have like a 4 gig model, is that 4 gig, at least 4 gig of memory use?
4 gig of memory use, just like being taken up by the model. So
is that how they size it? Like when they say 4 gig, it's 4 gig in memory?
So yeah, essentially when I'll show you, like literally 4 gig means like that's how much memory the app will be the model will be taking up on the device when you're running the model, when it's like loaded into memory. Yeah, so that's how big it will. So you can imagine if you're sending images and text through to this model, you're building up that memory quite quickly. Actually, Swift Transformers handles a lot of that, you know, caching for like chat interfaces. So like essentially if you send a message to a chatbot, it's sending another message through. Instead of you having to take both those messages, stick them together and send it back through so it has the context of the previous chat, Swift Transformers will handle a lot of that for you. So they've done a lot of the heavy lifting, taking it off your shoulders, so making it really easy for Swift developers to kind of pick out what they want to use. This is a model example, what to look for. So this is the Google MedGemma. This is the base model. So this is the big one that they use to then boil down into the smaller sizes. So here we got like the title, like the ID of the model, which is the Google MedGemma 1.5 4B IT. 4B is the 4 billion parameter mark. Over here you can see that it's the image to text. So this is a VLM. And then down here we've got the dot safe tensors. So the dot safe tensors is what you really want to look for. This is how much memory that the model is going to use when loaded to be run, right? So this one's got two safe tensors, so they're going to be run like side by side. So this model will run with about 8.6 gigabytes worth of memory being used up. So slightly too big to run on an iPhone. And this model has, again, zero quantization. So this is the base model, what a lot of these other models then stem from. So yeah, something like this could be run on like a Mac or something that's got a larger memory, essentially giving it a larger context. Here's another example. So this one is in the MLX community. So they have an MLX community of all of these models that you can run on device, anywhere between text, which is just basic chat, VLM. They also have ones that can transcribe from voice to text, essentially, and they can run that completely on device as well. Again, another thing to look for is image text to text. So this is a VLM, and then you've got the MLX tag here, which is going to show that it is MLX compatible, so it will run on device. And this previous model is not MLX, so it will not run. It needs to be converted into the MLX format. So this is in PyTorch. And then here you can see the dot safe tensors. This one's going to take up about 3.4 gigabytes worth of memory. And yeah, this is going to fit right inside the Goldilocks zone of how much memory you really want to take up. Because yeah, if you start messaging back and forth or building up that context window, you edge slowly closer to crashing the app, essentially, due to memory. And yeah, the smaller the bit, so the bit size on the end here, the more quantization the model has gone through. So there'll be like 16-bit, 12, 8-bit, 4-bit. So just basically shows you how much condensing the model has had. So then you can kind of see, you can kind of test and compare different models based on like what outputs you're going to get from these models. How do you run an MLX model? So the first step I would start with is going to Xcode compatibilities, and you want to increase the memory limit. So this is loading any of these models in for ages. It's just like, okay, why have I all of a sudden got 4 gigs? But it's like, yeah, it was quickly learned. So yeah, increase memory limit, and then the MLX Swift LM package, which will help you run LLMs, VLMs. That's been developed specifically with, it packages all of like the Swift transformers and all that sort of nice stuff together, so then you can just download one, you install one package and you're off. And then again, number 2, step 3 is like a simple class like this will help you run a model straight away. So you got the load here, you can load this one directly. This load will handle the download as well if it's not already found in like the Hugging Face cache on the device. You can pass in a model ID. So the model ID before was that one up the top here and up here. So you just click that little copy, and then you can pass that one into your load function. So that will just handle a lot of that. Is VLM, I've kind of just put it as like just a true false. And then you got your HF token, where if you've got private models and you want to download your own model, that's not open source with everyone else, you pass in your HF token here, which will then pull it from your own repository. And then you've got your ask and your ask, which is just a normal prompt. Same structure, same exact format as how you would prompt the foundation model. So they literally verbose the same code to prompt the foundation model as it is to prompt like a third-party model. And then you've got your VLM as well. So you'll pass the images in and handle the streaming of the response. And obviously you can do all your little animations and all that sort of stuff on the top of that to stream out the response for people. Demo time. So now this is the part where I show you a demo that I've cooked up to see if it actually performs or not. All right. You see some of my apps. Okay. Awesome. Get this. There we go. Excellent. Alrighty. So this is a version. Let's see if it works. Hello, is anyone there? Oh, there we go. Okay, that should be good. So this is Quen. So this is an is it downloading it? Let's just see, let's find out. Quen, which is made by Alibaba. I was also intrigued when I found out that this model was made by Alibaba, the same company that is basically an online stockist. I was like, wow, okay. And classic demo.
Do you need Wi-Fi?
I shouldn't. I thought I downloaded these before I got here. Unless, of course, let's have a look. Let's just run it. Get some stuff here. Oh yeah. Do I have Wi-Fi? Oh no, I got data. Okay. So this MedGemma skin model that I've got here is the actual model that we've kind of used and essentially trained to work specifically for our entrance, which is we're going to add something like a skin scan so you can scan your skin, and that way it's kind of got its prompt built in. So that's another thing I'll touch on later, like fine tuning. So you can fine tune the models so that the only outputs are based on essentially like your prompt. So you don't have to add your prompt in as context. So then you can save a bit more on that memory, and then it's like a simple thing like, for example, skin scan is like all the prompt you would need to kind of differentiate between skin scan, or another one we had was like a sunscreen extract. So like you could take a photo of like a sunscreen bottle and then it would like extract information from that sunscreen bottle. I think it's because we updated the model and now it needs to download.
That's my fault.
That's another downside as well. Like the initial starts to get people like, you got to get past that hump of like downloading the model, installing the model, getting it to run. Hugging Face
was saying it's 4 gig of memory. Like, what would that be in download size? Is it compressed somewhat compared to when it's expanded the memory?
I would say so. Yeah, it's like slightly
About the same.
Like about the same.
Like, yeah,
Okay.
yeah. So that file, if you go back to your slide with the file size,
Yep.
that's like the raw file size.
This one.
Yeah.
Yeah. Okay.
So that, what's 3.4 gigabyte? So that would be the download as well.
It's like how much entropy would AI model have? I think not that much.
Yeah, well,
It could not compress very much.
Well,
There's no lot of recurring structure.
well, what he was talking about, the quantization is like, so they start, most of them are trained in float 16 by default these days, but then that's too large to run on an iPhone, so you can quantize it down to 8 bits, quite common, but then for an iPhone you probably want something more like 4-bit, depends how much you start with, like, because it's a 4 billion parameter model, so in float 16 that defaults to like 9 gigabytes raw file. So yeah, just 4 billion parameters at about 2 bytes per parameter. And so, but yeah, even if you quantize it down to 4-bit, it's still, because it's starting from such a large footprint, it's still ending up at 3.4 gigabytes.
You're throwing that below it's a talks about, yeah, that's a small amount.
Exactly.
But if you start with the original model and you just try to cheese it or something like that.
Oh, yeah.
Compression algorithm, how squishy are they? How much redundant information is there that can be compressed?
A fair bit, yeah. So you can like with more, we're doing kind of like a rudimentary quantization, as in we're just almost doing a rounding of, you can do learned quantization. So a lot of the recent OpenAI open source models are like more learned quantization. So they're trained with quantization in mind, because they were sort of from the ground up built like that. Whereas this is sort of like a raw model file Google's put out, and then we've kind of had 2 weeks to build with it, so we don't have enough time to. Yeah.
Some kind of data does not have much entropy, you just can't compress it. There's nothing to it. There's no duplicate stuff to do. The compression of it. But text, for example, it's the same words happen with everything. There's always spaces. There's lots of patterns, and therefore they can compress them. So I was just curious, how much entropy do AI models have? How do they compress the water?
Well, this way.
Yeah.
I can take it.
We got Quen working. Yeah. So Quen was already installed. The other model was updated. So yeah, basically, it was in. If you saw me prompt it live, like it updates relatively quick. And then going back to the Xcode project, you can see the memory usage just starts like going up the more and more I prompt it. So let's just add a photo in here.
Is that your QuickTime program?
Did it? There we go. Can you see this?
Oh, nice.
Yeah. So, as you could imagine, like if you have like a text turn-based like sort of chat system, like your memory and the cache is going to build up extremely quickly. So yeah, that's something that I've kind of been like trade-offs. It's like where could you use like a cloud model based off, or could you use like an on-device model? A lot of the reasoning for like an on-device model I would basically argue for would be like if your app is doing the same thing over and over and over again, and then you can then start up one of these models and build it into context or like load it into memory when the user does a specific intent. So then it's just not just sitting around waiting for what's happening next, like a chatbot. So an example for Sunny is like the app that we're building is if you want to scan, say, your arm, we then watch when the user's like navigating through like the navigation system to log right forearm, and then as it's getting to right forearm, it's already ready to go. So then as soon as it hits the, like the image plus like the skin extract, it's for less than 4 seconds for like a response between like filling out the JSON. So it's like extremely quick, which is something that not a lot of people are kind of like, can give you a lot of wow factor when it comes to AIs, because a lot of AIs these days you just send something off and it's like, put the phone down, I'll wait till it's done. Or like you're on Claude and you prompt it and you like start scrolling through Reels as soon as you prompt it. Yeah. A few people here are guilty. So where's you next? So like after you've got like a model and once you've built a bit more of a basis, like my brother has, a bit of a nerd. So the base model with the same skin extract and an image, this is what we were seeing as a response, and it gives you it in it can give you it in like a markdown as well. So if you use something like a package, you can then display it similarly to how all the other models that people know of display it. Versus like once it's been fine-tuned, you're entering skin extract and we're getting like a much smaller output, and it's structured JSON as well, and you can make sure it's like the same every time. And yeah, that was just with a data set of like images that we've got from like was it like a dermatology sort of like skin scanning thing?
Yeah.
And then yeah, real world examples usually help the best when using these models as well. That was a big thing with Nutrify, building like the data set when we would just take a lot of photos like in real life, like how a normal user would take the photo, not like a Instagram like bougie looking plate of food. It's just like, it's gonna be crap, essentially. Yeah. Other helpful additions. So some models will be able to think. So you got to be tracking when the tokens, like when the thinking tokens. So they'll be like, okay, tokens thinking started essentially. They'll be like similar to like end token. It'd be like thinking started token. So it will just start streaming out tokens of like its thinking process, essentially building out larger context, and then tracking for when like the thinking ends and then the actual response is coming out. And then again, watch for the end token. There are some models out there as well, when I've been playing around with this for ages, like it would generate a response and then it would just continue until it broke of just outputting end token. Like it would just keep going end token. So monitoring when the end token and then stopping the generation. And then yeah, another helpful package I found was like the Swift Markdown UI, which was really great. Some models will just output Markdown by default, and then some models you can prompt them and just be like, hey, output Markdown exclusively. So yeah, essentially to wrap up my chat, there's like, I would say your on-device models are niche, especially if you're like a calorie tracking app or something like that that's doing the same task over and over again. If you're using an on-device model, you don't really need the whole world knowledge. You just need your model to know what foods are and what's what to point to where you need to go. Versus if you're building something, I guess, a bit more complex that needed a few more pointers in a few different directions, cloud's definitely the way to go. And then also, like if you're doing anything medical, having people know that like all of their data is like strictly on the device and not being uploaded anywhere else, it really helps you like circumnavigate a lot of those potential problems of data breaches or anything like that. It's like all held on device. So yeah, and then yeah, where to find me, contact me. That's my LinkedIn. And then yeah, I'm available for hire currently. Just do a bit of freelance work here and there, and then also working on my own projects. And one of them is, yeah, Nutrify, KeepTrack, and Sunny at this stage. But yeah, thank you guys for tuning into my MLX Swift Transformer chat. Any questions?
So for your app, so do you always use like pre-rolled models, or you have to do your own training?
So if I go back, so Nutrify, there's one pre-rolled model, I guess you could say, which is Gemini 2.5 or Gemini 3.0 Flash, and then KeepTrack is built specifically on Gemini as well, so that's completely online. In terms of training or like any like custom models that we've made, Nutrify does run 2 custom models. They're like in the Core ML format, so they're extremely fast, like milliseconds worth of like a response based on like, and they run on the neural engine. That's another big thing, is like the MLX framework has been built on using the chipset's GPU, because it's, if you're using an LLM or a VLM, it's constant updates, like streaming through. So like the tokens, versus like a Core ML, which is using a neural network, they're much more better at like one shot essentially. So it's just like a different, they're set up completely different essentially. But yeah, Nutrify does use the old format of Core ML, and they were like custom trained as well. So like my brother, we went around taking photos of like foods with our phones. Another one was like, we were talking to some other people about dog poo. Like, it's a food tracking app, we didn't want dog poo, so we actually went around and took a whole lot of photos of dog poo, toilets, like anything. So it's just like, we didn't want people to be able to take photos of things that aren't food. So then we don't have to then like keep the database kind of like, get rid of all these other images that people may upload. But yeah, these two both run Geminis. Yeah. And then another big thing as well, like with Nutrify, another thing we found in terms of just using a cloud model, having a lot of like your data structure like on device as well. So Nutrify has like a massive JSON worth of like 1,000+ foods. So essentially we're using Gemini as like a classification. So it's like, hey, what foods are in this image? And then we can just point to our database and pull that all locally. And then it's really just like condensing the amount of work that we actually need the AI to do. And they're actually really good at classification. In some cases, it still stuffs up our sweet potato, which is, I don't know how, like it will always throw like an error on like sweet potatoes. No matter how much prompting goes into it. No matter how much prompting, it's just like, yeah. But yeah.
Good question. So to load the models in that, you're saying 4 gigabytes and maybe the 6 to 8 actually models.
Yep.
So when your app's running,
yep.
so you have that RAM. Are there issues with thrashing where some other application or process evicts it because it's so big?
Okay.
Was that just not a thing?
I don't think it really happens. Like a lot of, it's really, in my experience, it's been pretty good. Okay. Like it will, in terms of like all of the other background tasks, it knows to kind of like drop them for now. Like it's utilizing like the extra memory of essentially like the models or whatever. You will run into crashes obviously with memory when you're playing around with this much memory sometimes, especially like if your iPhone only has 6 gigs and you're already loading in a model that's got 4 gigs. So it's like, you don't really have long until it's going to like potentially crash out.
Yeah, open though, you're probably okay.
Yeah, exactly right.
So if you change it, does it kill it? Like how long are you got? You jump in the messages, reply to a message, come back with a Kobe model?
No, it will actually like persist, which is crazy. Like it will stay there as well if you're jumping across. Maybe after like a certain amount of time, it will kill it. Yeah. I'm putting in Sunny like a timer, so like when it stops working, because it's built on like an intent. So basically, asynchronously, if it stopped working for after 2 minutes, let's drop the model. Just in case if the person wants to then boot up and do another scan, they don't have to wait for that initial load into memory. Like it's already there, even though it only takes like a second or two to do that. And it all happens like asynchronous. So you can keep like the UI going nice and smooth as well, so they don't even know that you're loading like a 4 gig model up in the background. And then you can give them the nice response once you've taken the photo, or in Sunny's case, once you've taken the photo. Yeah.
Do you know if it can take advantage of like swap memory on like Mac OS, like with some of the context or whatever? Like if you're like feeding it in and having a bit of a chat back and forth, do you think it can take advantage of like swap memory?
I haven't really played around too much on Mac.
Yeah.
I do know that they can run on Mac because like the MLX like is like cross-platform, so it works on like all Apple chipsets. I've specifically dabbled in like mobile, but yeah, I don't see why not. Essentially, like it's working the exact same way as it would work on like every other platform, kind of like how Apple like doing things. So it's just the one way to do everything. But yeah, I feel like the next step would be to try it on like a Mac and see what it's like to loading maybe in like a Quen model or something that's good at code, and then just having to play around to see how much of a context window you can kind of get out of it. Obviously it depends on your specs because it is all in memory. But yeah, I've only experienced, I can only speak on iOS side of things, but that's a cool one. Yeah, you could literally make your own essentially chatbot like code private as well. So if you've got anyone that you can't upload code to any other, if you have to use Copilot or any of those other companies, like you could make your own now with MLX. Yeah, exactly right. You know it's safe, it's not going anywhere, you're not going to leak any confidential information to anyone. Yeah, it's just all going to be on your computer.
So lately, Apple Research published something on a paper on running the language models not from RAM but from flash memory or something, which seems like it's super like important.
They did. I know the paper you're talking about. It was more for like offloading. If you had a model too big to fit in RAM, you could offload some of the unused parameters essentially to the flash memory, and then randomly access it.
Yeah.
I don't know how productionized that is. That may be in the background of MLX, but I know what you're talking about. Yeah.
Yeah, just wondering, like with the current like, context window that can run on the iPhone, how much back and forth conversation can that last?
Yeah, it's all. It's we could.
Yeah, I'm just curious.
How many VPlex can you upload?
Well, it all really depends because there's tokens in, tokens out essentially. So like the models, like the images are getting like turned down into tokens, plus like the text as well into tokens. So it all adds up pretty quickly.
Surely images are using a lot more tokens, right?
Yeah. So it's like stringing the image out into tokens, feeding it to the model. Model does math. Model returns text. Well, tokens get turned into text.
What actually puts the upper limit on context window?
The upper limit?
Yeah, like what is it, hardware based?
You can it's like hardware based essentially. You can also like code in a limit. So where it's like, okay, once we hit a certain amount of memory, prompt or say like, no more essentially. But yeah, like in terms of hardware, like with everything on device, your limitations are literally
Yeah. Like when OpenAI says it's 200,000 tokens, like why did they set that limit? Is it like built into the model, or
could be potentially so they don't lose money? So it's like because if they're running, because they'll have to run their models on servers, so they've got a limit as well, but also to run those expensive servers, they'll have to cap your context, otherwise.
So it's like service limits themselves.
And it's also like what it's been trained on, like as well. So it might have only been trained on 256K context. And then like an NVIDIA like H100 GPU has like 8 gigabytes of VRAM, but they're stacked in a machine of 8, so that's 640 gigabytes. But if their models are like 1 trillion parameters versus 4 billion parameters, and then it's a combination of like just exactly the problem we're running into here, but scaled up to.
They also tend to get worse output when you're like in the middle of your context window. They pay more attention at the start, and then as you get towards the end,
Get it to generate like
in the middle, it's
code for the app.
Context.
Yeah, right.
Write a chatbot in MLX.
Doesn't look like it jumps up like heaps though, like feeding at the images. Like you jump
It's not that bad, eh? Like it's,
yeah.
4.47 gigabytes.
How do you find the difference between using like a world knowledge model, like a general purpose one, versus with like a tailored prompt versus
that's pretty quick.
specific training?
Yeah.
Specific training. like versus like a world model, like a general knowledge model.
Smaller models where you're tailoring them a little bit more.
Kind of like how we tailored like before I showed the example where it tailored the like the output from the MedGemma to just be like a specific JSON.
Yeah, exactly.
It's going to be good. It's using a lot of CPU. It's hanging in there. This is crazy. In terms of performance, it's hard to really. You're getting like one.
Well, I can talk to that.
Well, yeah, you're getting smaller context windows. You're getting faster responses because it kind of trains.
I mean like quality of the result.
Quality.
And like throughput.
Yeah,
so
okay.
the base model can output the structure that we're after, but the reason why we fine tune is so that it basically only outputs that structure. Okay. So when you have like all generality, it can output anything, and it's sort of you controlling it by a prompt. And these smaller models are a bit harder to, like, just you talk to modern ChatGPT and it'll output like a JSON every time basically now. Whereas a smaller model doesnn't have. Like it will output that JSON, but sometimes it'll output extra tokens. Yeah. The reason why we fine tune it so like it's specific for that use case. So then in the UX we can go photo of skin, you know, pretty much guaranteed you're going to get the structure out of what you want. And then because every token counts on device, you could put in a prompt that's like 100 words long to say output this JSON structure. But we just changed that to just skin extract, so that you put in 2 words and it'll always output the same structure, so that we don't have like this long context window. Because every time you have to process a token, it takes processing time.
I just googled and apparently the iPhone here is 12 gigs of RAM, so you've probably got quite a bit.
12 gigs?
Yeah.
Oh, I got ages.
You probably got quite a bit like on the newer devices.
That's cool.
The base 17 has 8, the Air and the Pro 12 have bumped it.
That's crazy.
Didn't know that, but yeah.
Yeah, so yeah, it comes back to that question. Yeah, it's a lot of like hardware limitation. It's like how much you got on your device essentially is how much you can really push these.
What's
models.
the quality of the code there, Josh?
No, I asked it to print out UI kits, so it's like dog water. But yeah.
The real test is when you put on airplane mode, just to make sure it's on device.
Just to make sure I'm not actually
Yeah.
It's like going with your
Yeah. You sure that isn't an API call?
No.
It's really
Well,
You still got Wi-Fi.
It could just be loaded in. I'm just now streaming it through in a Witchcraft.
This is very cool.
No, but they're really cool. And like I said on Hugging Face, there's heaps of different models for different purposes. Like there's kind of, you can kind of build an app idea around some of the models and how like niche they've made some of them as well. Like for example, you got a Whisper Flow or whatever it is, like Windsert, like you talk to your computer and it turns it into words, and then you turn it into an AI. You can essentially just use like an on-device model to then that's trained on basically turning voice into speech and spin up like a small little like Swift code, and then you've a Swift or Mac app, whatever, and then you've basically replaced your. Obviously, you might have to do a bit more work than that, but yeah, there's like little use cases like that. So you can go and find one of these models that's like highly trained on like a specific task, and be like, oh, I could build a whole app around that. Like there may be a VLM that's specific on birds or something like that. So yeah, as the bigger models grow and grow and grow and get better and better and better, a lot of these little models coming up behind are actually pretty decent, and can give you really decent outputs as well. So yeah.
Sometimes when I've heard open source models released, they say they haven't open sourced the weights. What does that mean? Is that like the post-trained weights or something against the model?
So
Potential.
yeah, so usually what happens with like a Quen model, for example, when they say open source, they usually only open source the weights, not like the training data or the training code, because they actually can't release the data because the data is the entire internet. And that's the sort of the secret none of them really want to say, but everyone knows, is that we basically scraped the whole internet and trained on it. So they can't release it because it's like, well, then everyone will sort of know that you stole all of our data.
What do we do from scratch?
Yeah, exactly.
Unless also you're ChatGPT and then you just like show, hey guys, this is Sora. It just happens to know how to make all of your animated videos. Like Simpsons, Family Guy. It's like no, we didn't train on it. It just knows.
I mean, Wikipedia is probably not a training section to pretty reasonable model. You can download that.
Yeah, true.
No, you're definitely right. Yeah, that's like GPT-2 was basically just only Wikipedia.
Yeah, and it's probably the highest compared to the open internet. That's high quality.
What, you don't want the Reddit forums in your model?
Wikipedia stuck out of the front.
There's not too many sources of data that actually have any level of quality compared to the internet.
You could do what Facebook do and just download MedGemma, like the Shadow library with all the pirated books.
Yeah.
Yeah.
Companies like do it.
Yeah. Like crap.
I mean, aren't they at the point where they're generating their own training data now?
Yeah.
Synthetic loop.
Well, all of the data we used for MedGemma was synthetically generated for our fine tune. We've got another model to make that, so we siphoned Gemini for that. Like it's for we're not sort of productionizing it. This is just because we're in a sort of, it's only had 2 weeks, so we sort of, if we were to make Sunny like a real thing, you could definitely do a lot more rigorous stuff around creating a data set. But because it's like we had a 2-week timeline, we just, the quickest way.
So the thing Sunny does is like, an image goes in and it says whether or not it's like, worry about no about yes or no.
It can't be diagnostic.
Well, there's a big warning. It's not diagnostic. It just describes it in dermatology terms, and then, which is optional. You can turn AI off in Sunny, but we're kind of playing into the Google competition where you kind of have to use the model as like so that's our use case for it. And then, but then the idea of Sunny is you would discuss that with the doctor. And that's also a big caveat, like all the medical sort of AI models that get published are like all basically, hey, these aren't diagnostic tools. Like they're basically like a prompt to get you to go to a doctor. Yeah.
This is like you buy mass like TGA approval or something.
Exactly, yeah.
This is not a diagnostic tool.
Yeah.
So how far along are you guys with the app, like, that you got building with it for the diagnostic of?
Can you show something?
I can show a little bit. It doesn't
Get a
work.
rash on it.
Can you try like a freckle or something? You might
I did have it. I've currently like kind of started restructuring Sunny, so like how it would work, like and how you would be able to track photos and all that sort of stuff. So I did gut it, but this is essentially what you get here. Like front and back SVG image, so you can highlight areas where you have scanned, where you haven't scanned. And then down the bottom here, we've got just like a percentage as well. So you got photos, scanned, updates. I've got an onboarding. I'm building out like the saved, where we're going to put all like the saved information, and then just like a step through of like how you would put a new scan in. And this is what I was talking about, where the intent. So like once you're opening up the intent, it's like, okay, the user's opened up like the add tab, so they're potentially just going to be scanning something, so we can get the model ready to get ready to scan for something. But yeah. I broke Sunny in the process of doing something, so I can't actually show you a live demo of how it works.
Yeah, not for you. It looks really nice.
No, I still thought I'd show it off. But yeah.
Oh, okay, good.
Most interesting part was SVG image, and then just like making sure you can track and then like highlight and show like, I guess, annotations pointing towards like, this one was taken, like you got 1 photo here, 4 photos here, whatever, all that sort of stuff. So then once you hit this dashboard, you instantly know, like from a glance, you can see your body coverage, what you've got, what you've scanned. So then essentially when you go to add another photo, you could like blur or like drop the opacity of the previous photo. So then they can then get a direct photo over the top. So then your scanning is just consistent as well. So then you can get that good side-by-side comparison of the
Did you
photos.
say SVG?
This is an SVG, yeah.
Did you find a good library for that?
Yeah, there's a pretty good one actually. I found it was.
So also clunky last time I needed one.
They are pretty clunky. Yeah.
A lot of these.
I found a literal YouTube video of a guy going through, like, this is like, for ages I was trying to get Claude or someone to help me prompt through one, but then I found a YouTube video of a guy doing a tutorial through how to set up. It was actually how, like, picking parts of a bicycle. So it was like, it would be like, select the seat, and he would like click on the seat, and it was like a weird random video like that the algorithm served me up. and it was perfect for the use case. So yeah, it essentially will allow me to like pull out all of the IDs for all the different areas. So then I can then turn that into Swift code. Then I can track where they are as well, and change colors as well. So you can change colors of the whole thing. Then you got positions as well because it's an SVG. So then you can use Swift to then put annotations wherever you want them. And then yeah, front and back as well. Yeah.
Awesome. Thank you very much.
No worries. Thank you guys. Thank you very much.